Hello sir, my name is Kriti HD and I'm from 4th Sem B section and I'm going to explain about the differences between microcontroller and microprocessor. A microprocessor is a processor where the memory and I/O components are connected externally. A microcontroller is a controlling device wherein the memory and I/O outputs component are present internally. Microcontrollers and microprocessors are both important components in the field of computing, but they have different characteristics and applications. Here's a key breakdown of their key differences. Architecture. A microcontroller is a single integrated circuit that combines a microprocessor core with peripheral device like memory, timers, and I/O ports on a single chip. It is designed to be a self-contained system and is commonly used in embedded systems. Microprocessor. A microprocessor, on the other hand, refers to a control processing unit of a computer. It focuses primarily on uh, processing data and executing instructions without built-in peripherals. It relies on external components to fulfill other system requirements. Integration. Microcontrollers are highly integrated devices. They often include on-chip memory like RAM, ROM, and EEPROM, I/O ports, timers, counters, and other peripherals. These integrated components allow microcontrollers to function as standalone systems with minimal external components. Microprocessor. Microprocessors are typically less integrated and rely on external components. They fulfill various system requirements. Memory, I/O ports, and other peripheral are not integrated into the microprocessor chip itself. Applications. Microcontrollers, due to their integrated nature and low power capabilities, microcontrollers are commonly used in embedded systems and applications that require controlling, sensing, and automation. They are found in devices like consumer electronics, home applications, industrial automation, automotive systems, and more. Microprocessor. Microprocessors are primarily used in general process computing devices such as personal computers, servers, laptops, and high performance systems. They are better suited for tasks that require extensive processing power and multitasking capabilities. Flexibilities. Microcontrollers. Microcontrollers are oftenly programmed for specific tasks and are less flexible compared to microprocessors. They are optimized for their intent applications and may have limited resource for running complex software. Microprocessor offer great flexibilities and they can run a wide range of software applications and operating systems. They can handle diverse tasks and can be reprogrammed to adapt to different requirements. In summary, microcontrollers are integrated circuits that combine a microprocessor core with peripherals designed for embedded systems and specialized applications. Microprocessor, on the other hand, are the CPUs of computer, focusing on processing data and executing instructions, and are used in general purpose computing device. Here are some more differences between microcontroller and microprocessor. A microcontroller is a compact integrated circuit that combines a microprocessor core, memory, and input-output peripheral on the single chip. It is designed for embedded systems. They have built-in memory like RAM, ROM, and or flash. Microcontrollers are cost-effective, power-efficient, and offer real-time controllers capabilities. They are usually programmed using low-level key language such as C or symbol assembly, and their software development often involves working closely with the hardware. And some of microprocessor is a CPU that focus on executing instruction and performing calculations. Microprocessors generally have higher clock speeds, more powerful instruction sets, and larger addressable memory. They are capable of running complex operating systems, for example, Windows, Linux, and executing high-level programming language such as C++, Java, or Python. Microprocessors are commonly used in applications that require extensive computation, multitasking, graphical user interference, network capabilities, and software flexibilities. And next part will be explained by my friend. Thank you.
Hi sir, I am Kishan VV from B section. Today I am going to explain the introduction to ARM processor. These are the topics. First one, introduction. Next, ARM architecture, applications, features, advantages, disadvantages. First one, introduction. Advanced RISC machine ARM processor is considered to be a family of central processing units that are used in music players, smartphones, tablets, and other consumers' electronic devices. Advanced RISC machine create the ARM processor architecture, hence the name ARM. This need very few instruction set and transistor. It is very small in size. This is the reason that it is a perfect fit for a small size device. It has less power consumption along with reduced complexity in its circuits. They can be applied to various designs such a 32-bit device and embedded system. They can upgrade according to the user needs. Next, ARM architecture. The ARM architecture is the keystone of the world's largest computer ecosystem. It enables our partners to build their products in an efficient, affordable, and secure way. ARM's architecture specification are by partners who create compliant silicon chips based on them. Next, this is the ARM architecture block diagram. Next, application. The application of the ARM process start with getting knowledge of the ARM processor history. Before ARM, x86 processor were used, which were launched in 1978. Whenever we remove the predefined instruction like complex instruction and hard to implement instruction, the remaining instruction take less power and this and hard to implement instruction. The remaining instruction take less power and makes the run faster. This is called a reduced instruction set computer architecture. x86 is a complex instruction set architecture. This is the block diagram. Next, features. First one is a multiprocessing system. Next, tight coupled memory management. Next, thumb 2 technology, one cycle execution time, a large number of registers. Is multiprocessing system. ARM processors are designed to be used in cases of multiprocessing system where more than one processor is used to process information. The first AMP processor introduced by the name of ARM is 6K, could support 4 CPUs along with its hardware. This is the block diagram. Second one is tightly coupled memory. The memory of ARM processor is tightly coupled. This has a very fast response time. It has low latency that can also be used in cases of cache memory being unpredictable. This is the cache memory block diagram. Third one is memory management. ARM processor has a management section. This includes memory management unit and memory protection unit. These management system become very important in managing memory efficiently. This is the black diagram. Thumb-2 technology. Thumb-2 technology was introduced in 2003 and was used to create variable length instruction sets. It exits the 16-bit instruction of each thumb technology to 32-bit instruction. It has better performance than previously used thumb technology. This is the thumb-2 table branch instruction. Next is thumb-2 encoding. Next, one cycle execution time. ARM processor is optimized for each instruction on the CPU. Each instruction is a fixed length that allows time fetching future instruction before execution the present instruction. ARM has a CPI clock per instruction of one cycle. A large number 61 is a large number of register. A large number of register are used in ARM processor to prevent large amount of memory interaction. Last one is pipelining. Processing of instruction is done in a parallel using pipelines. Instructions are broken down and decode in one pipeline stage. The channel advance one step at a time to increase throughout the rate processing. This is the black diagram of pipelining. Next, advantages. ARM processor deal with a single processor at a time, which makes it faster and also consumes lesser power. ARM processor work in the case of a multi-programming system where more than one processor is used to process information. ARM processor are cheaper than other processor, which makes them usable in mobile phones. ARM processor are scalable, and this feature helps in the using a verify the devices. Next, disadvantages. ARM processor are not stable with the x86 processor, and due to this they cannot be used in Windows system. ARM processor are not capable of very high performance, which limits them to a variety of application. ARM processor execution is a little hard, which requires skilled programs to use it. ARM processor is insufficient in handling scheduled instruction. Thank you.
So hello, my name is Krishanu Shekhar, and today I'm here to give my presentation on the topic, which is ARM architecture. ARM architecture, the future of cloud computing. Also, uh, I'm from section B. This topic. So central processing unit CPUs can be compared to the human brain in that their unique architecture allows them to solve mathematical equations in different ways. X86 is the dominant architecture used in cloud computing. At the time of this writing, however, it is worth noting that this architecture is not efficient for every scenario, and its proprietary nature is causing an industry shift toward ARM. ARM Advanced RISC Machines is a type of CPU architecture that powers most tablets and smartphones, as well as fastest supercomputer in the world. Supercomputer Fugaku ARM's low power consumption and high computational performance make it a worthy reveal for 8286 in a cloud computing. In this article, I will talk about a few popular projects, the main difference between the Into86 and ARM architectures, and explore how we can prepare developers for the future by providing them with an ARM-based container environment. So ARM versus Into86. Companies are increasing in their pursuit to leverage ARM in order to reduce both cost and energy consumption. While Into86 remains a proprietary CPU architecture, ARM provides licenses to other companies, allowing them to design their own custom-built processors using ARM's patented technology. Amazon's custom designs Graviton processor is a great example of ARM in cloud computing. By using these processors, AWS A1 instances offers a comparable performance to into 86 EC2 instances while saving 40% in costs. The main difference between ARM and Into86 can be traced back to the way these CPUs execute instructions. As an example, an ordinary Into86 desktop CPU uses an implementation of complex instruction set computer architecture, allowing for a single instruction to execute multi-step operations in each clock cycle. ARM, on the other hand, uses an implementation of reduced instruction set computer risk architecture, allowing it to utilize a limited, highly optimized set of instruction to execute a single instruction in each clock cycle. ARM containers. Before I continue, let's address the elephant in the room. You might be thinking many container runtime environments like Docker can use the buildtext command to create containers for a variety of CPU architectures. So why are we even having this conversation? Also, Docker build platform can create a platform specific image. You cannot run commands that execute binary files from your recipes. In the following example, you can see a failed build due to the difference between the host and binary architecture types. Containers share CPU and kernel with the host, which means the underlying hardware dictates which instruction set can be used in the container environment. This can be highlighted in red. In the previous Docker build, output executable programs that we use are compiled as binary files. Compilation is a magical step in the software development process where a compiler software takes a piece of source code, arguably human readable, and converts it into binary machine code. Example ones and zeros that is specific to the CPU. In simple terms, programs are made by other programs. There are interpreter-based languages that can directly execute instructions from the source code, but let's not dive into that abyss. Linux to the rescue. Packed with features, the Linux kernel is a modular piece of software that can be extensively customized based on your usage requirements. One of these features allows you to run almost any binary files into your system by using an interpreter regardless of the binary compiled architectures. Linux can be configured to use FFT, MISC, and match the beginning bytes of a binary file to identify which interpreter is suitable in order to execute it. In our case, we need to run everything using an interpreter that can understand ARM64 CPU instruction, WinFMT, and Linux kernel are huge topics and out of the scope of this articles. But if you are interested, yeah, Project Multi-Arc uses some concept to register QEMU as an interpreter, allowing users to emulate various CPU architectures for containers. Thank you.
So, good morning, everyone. I'm Lishaya, and my topic is about the embedded system. So, first, we'll know about what is a system. A system is an arrangement in which all its units assemble, work together according to a set of rules. It can also be defined as a way of working, organizing, or doing one or many tasks according to a fixed plan. So what is a system? I would like to take an example regarding system. So we'll take a watch as an example. A watch is a time displaying system, and all its sub units, that is all its components, if it's stopped working, so the time does not show time. So I can say that in a system, all its sub components depends on each other. So it is meant by system. And next comes the embedded system. Has its name suggests, embedded means something that is attached to some other things. An embedded system can be a thought of a computer hardware, a system having software embedded in it. The embedded system will be having software in it. An embedded system can be an independent system, or it can be a part of a large system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific tasks. So embedded system is which is a computer hardware which holds the software in it, and embedded system is an it is independent of all the systems. And embedded system contains microcontroller and microprocessor based designs in it. So what are the components regarding the embedded system? So the first component is about it has a hardware. The second one, it has the application software. And the third one, it has a real-time operation system. And the characters regarding the embedded system. The first one is single functioned. An embedded system usually performs a specified operation. It only performs a specified operation, so it is called the single function. And the main one is the time. Many embedded systems must continuously reach to change in the system's environment and must compute certain results in real time without any delay. So without any delay, the function should happen. So time is very important. The next one is about microprocessor based. So it must be a microprocessor based or a microcontroller based. So the next one is the memory. As we already know, the memory, it must have a memory, has its software usually embeds in ROM. It does not need any secondary memory in the computer. So the memory is like the main part, so that it does not need any secondary memory. If it have a software, usually it will be always there in it, that will be embedded in ROM. Next, connected. It must have connected peripherals, that means to connect input and output devices. Next, HW and SW, that is the hardware and software systems. The hardware is used for performing performance and security. By the way, the software is used for more flexibility and good features. So the main advantages and disadvantages of the embedded systems are: the main advantages: easily customizable, low power consumption, low cost, enhanced performance. Performance is enhanced, it is of low cost, and it is a low power consumption. But the disadvantage of it is it is high development effort, large time to market. It takes large time to market. The next one is Basic structure of an embedded system. So it looks like this: sensor, AD controller, DA controller, processor, actuation, and memory. So as we already know, what is a sensor? It measures the physical quantity and converts it to an electrical signal. So as analog is converted to digital signals, a sensor, as we already know, that can be A to D converter. A sensor stores the measured quantity to a memory. So what is an AD converter? That is analog to digital converter that converts the analog signals sent by the sensor, that is sent by the sensor to a analog, then that will be converted into digital signals. And the next one is the processor. Processor process the data to measure the output and stores it in the memory. As we already know, the processor that stores the memory. Next, DA controller, that is digital to analog converter, converts the digital data fed by the processor to an analog data. So thank you.